Question 7.
From the previous test?
Yeah, on test number 3.
Was that the log?
Yeah, begin by graphing f of x equals log x, and then use transformations.
Of x plus 3 minus 1?
Yes.
Okay, let me just show you. These are the classes from last week, and this is what they asked your class, the other class at 2 o'clock. This is what they asked. Isn't that cute?
I'm glad I'm not the only one who wants to know.
Isn't that cute? Exactly the same problem. Okay, very good. So, first of all, we know that log is not a friendly function. By saying that, I really mean that the domain is not all real numbers. So if you remember, we have to write this, which gives us this, which gives the domain -3 to infinity. Is this okay?
Yes.
Good. So obviously the base function, not the base of the log, but the base function is log x. And we know the graph because the base is greater than 1, not exponential, but log. The graph looks like this. This is log x. Obviously, after that, I need a shift, a left shift. So log x plus 3 is left 3. And then number 2 is log x plus 3 minus 1, which is down 1. So having the graph of log x and then the first transformation I have to shift 3 to the left because I know now it's clear why. The domain is -3 to infinity. But this is a function with a vertical asymptote at 0. When I shift the graph, this asymptote shifts first. So I'm going to graph now the vertical asymptote, which is x equals -3. And then I will move this point 3 units to the left. That's my reference point. So 1, 2, 3, right here. So here's the graph of log x plus 3. Final step, of course, I have to shift this down 1. Not a big deal. Right here. So my marker, or if you want, my reference point moves here. So this is final. So this is log x plus 3 minus 1. Very good question. Good. Next question. Anything? As I said, today is your day. Take advantage of it. I wish my professors would have said that. I would have jumped on it. Anything you need help with? Yes, I'm ready.
Okay, so this is from, I think it's 4.4. And I don't know why I was having such a hard time with it, but this problem is 9 ln 7x.
Oh, I'm sorry. I'm sorry. You were dictating. I'm sorry. No, I couldn't hear you for a moment. You're breaking up.
Sorry. So it's 9 unnatural log 7x equals 45.
Perfect. Very good. So we want to solve for x. And our first step, of course, always keep in mind, in the back of your mind, there are 2 commands that you should never forget. Simplify and factor. Always think in terms of simplifying and factoring if they are applicable. They're not applicable all the time, and just in this case, I have to get rid of this. So I have to divide both sides by 9. And now this is completely cleaned up. at 7, a natural log 7x with parentheses or not, it doesn't matter. And I have 5. Now, this is the opportunity to apply the most important topic that I consider the most important topic in this chapter, in chapter 4. Changing a log equation into an exponential. And the exponential, if I need to, back into a log. So I have to identify the base. Because we go counterclockwise, the base raised to this number equals 7x. But what is the base? I don't see the base.
It's E.
E. So then e to the 5th power. E to the 5th power equals 7x. Therefore, x equals e to the 5th divided by 7. Now, this is a log equation. I should have written from the very beginning that x has to be positive. It is. This is a big number divided by 7. It's positive. So it is yes. But it's a log equation. If I don't intend to go back and check, I have to state the domain. I never intend to go back and check. It's easier for me to write the domain, but you don't have to. But you have to go back and check and make sure it's correct.
Okay.
Is this okay now?
Book had yeah, that is helpful. I think part of my confusion, and I want to see if there's any validity to this, in the book, when it's teaching about solving logarithmic equations, it has a problem it's basically identical, just different constants. And one of the steps, it says to rewrite the natural logarithm showing base e, but instead of ln, the book shows log base e to the 2x. And I thought, that looks a little weird, but I thought I'd bring it up.
So what they do, which I think is more difficult, they are changing the 5 into natural log e to the 5th power. Because natural log e to the 5th power is 5 times natural log e. But there is no need to do that. Because this is a very important concept. We can not know this concept. So this is the easiest thing to do. E raised to this power equals that. You cannot change this into log. You have to change it into the same log. It has to be the same log. If I have here log, then I have here log. If I have here ln, I have to have here ln. I
think the book just had a typo because it was really screwing with my head.
No, yeah, they made an error.
Thank you.
Is this okay?
Yeah, that was helpful.
Good. Very good question. Next question, anything?
Can we do number 9 on the test?
Yes. What does it say?
This one is, it says use the properties of the log to expand the expression as much as possible. And it says log base 4 with the 7 square root e to the 6.
Look here.
So I just need to watch last class video.
No. Let's do just that. So it's log of the 7th root. I should have copied it and not put it away. That's so funny. They asked the exact same question. Okay, is base 4, and this is a to the 6th, b minus 1 to the 3rd divided by 16. Very good. Okay, so obviously I have to start with the power. And the power basically is power 1 over 7, right? The 7th root. So I have to put 1 over 7 in front. And then I have log base 4 of a to the 6th, b minus 1 to the 3rd divided by 16. Now, remember what we said a long time ago? That the quantities that come from the numerator will have plus in front. The quantity that comes from the denominator will have negative in front. So 1 over 7 stays outside. Log base 4 of a to the 6th plus log base 4 of b minus 1 to the 3rd, but minus log base 4 of 16. Is this clear so far? Is that okay?
Yes. It's just a lot.
Yes. Yes. Review part 7. Okay. In the next step, we have to deal with the powers, but also calculate this. So we're going to start by calculating this first. So I'm going to do it here on the side note. So log base 4 of 16 is a number. I'm using the exact same property. Log base 4 of 16 is a number. For raised to which number is 16? So this is equivalent to 4 raised to which number equals 16. So then what could all this be replaced by? And the answer is?
2.
Yes. The answer is 2. Only 4 squared is 16. And now we continue. All we have to do is bring the power in front by the power rule and then distribute 1 over 7 to all 3 terms. And it's done. So 1 over 7 times 6 over 1 is 6 over 7 log base 4 of a plus 3 multiplied by 1 over 7, 3 over 7 log base 4 of b minus 1. Now this was replaced by 2 and I have to multiply by 1 over 7. And this is it. Is that okay?
Yep. Can we do number 12?
Yes. From the same? From the same test? Okay. What does it say? Do I need to open it?
Solve the following equation, express these exact solution.
Yes?
No, it's e raised to 11x minus 5 minus 3 equals 28498. 28,498.
Very good. Perfect. What will be the first step here? What do we need to do?
Adding 3.
Excellent. So e to 11x minus 5 equals, when I add 3, I have 1 and 0 and 5. Correct me if I'm wrong. Okay. What next? I need to bring down the power. What should I do? What should I apply to both sides to be able to bring down the power?
Natural log.
Exactly. Exactly. We're going to apply natural log to both sides. Perfect. I'm deleting these videos so I can't. Okay. Done. Perfect. Okay, so we apply natural log to both sides. I bring down 11x minus 5, and I should write times natural log e, but why I don't? Because natural log e equals?
Because it's just
They
one.
cross each other out.
Because natural log e equals 1, if that's what you meant.
1.
Yes. So this is natural log of 28501. Now this is linear. Don't get bothered by, where's my eraser? Right here. Don't get bothered by that. This is just a number. I have to add 5 and divide by 11. So x equals 5 plus whatever that number is over 11. Natural log 28501. And this is the exact. If you want to check, you will have to approximate it. Although you could check without approximating it, but yeah.